Hello and welcome to Conf42 Platform Engineer 24. I'm Harel. I'm going to talk about developing and creating Terraform providers. We'll talk a bit about an ISC refresher, what's infrastructure as code, where do I start when I want to create a provider, and how do I go about creating a provider, including a live demo. First of all, I'm Harel Safra. I'm a data platform engineering team lead at Riskified. My team manages all the online databases, everything that has to do with online systems and access either to end customers or to analytical systems. Infrastructure as code is a programmatic definition of infrastructure elements. It allows repeatable, documented processes. You don't have to click through UIs or do the same manual task again and again. And there are two general approaches to how you go about infrastructure as code. First of them is declarative. The user defines what they want to achieve, and then the platform framework does the work for them and provides the infrastructure. The other one is imperative. The user defines how they want to create it. They iterate over loops. They create the code or code-like structures that go ahead and create infrastructure elements. And we can contrast Terraform and Pulumi on either side. Terraform providers are the plugins that interface with the infrastructure API. Terraform core is a framework that knows how to create an object, an infrastructure element, but doesn't have any idea about how the infrastructure is created and managed. To interface over that, we create Terraform providers that interface between core and the infrastructure API. And Terraform core interfaces with a provider over RPC. As of today, there are 4,400 plus providers, and the list goes on and on. And the main thing to remember is that anyone can create more providers. You don't have to be any versed in Go. You don't have to be part of the infrastructure team. You don't have to be part of the product or the company at all. When I need to create a provider for an external database that can be used in my team, but I was not part of the database development. So anyone can create one as long as there's a public API that allows you to interface. So where do I start when I want to create a provider? The first is understand a bit about the architecture of the process. So we have Terraform core on the left side. And Terraform core is the executable that you run and manages the operations. It knows how to create infrastructure, it knows how to route infrastructure, and it knows how to calculate deltas between the needed state and the current state. It interfaces over RPC with a Terraform provider. That's a plugin that you will develop. And that Terraform provider, that's written in Golang specifically, interfaces with a client library. And that client library interfaces over native protocol with the infrastructure. The native protocol could be HTTP calls, gRPC, SQL, system calls, REST API, anything that infrastructure knows how to understand and implement. The API, you need to find the correct API to interface with the infrastructure. There could be old versions, new versions that are easier to work with. But if there's a version that has an existing Golang client for it, I would advise to go for it because it will be easier for you to create the plugin with that. Obviously, as I mentioned, the provider is written in Go, so you need to know Go, understand it. Go is a compiled and high-level programming language. You need to understand and get versed in Go. You don't need to have a specific deep understanding of it. You can use Google, ChatGPT as you go along, but you need to understand the constructs, control structures, and anything like that. There's a good step-by-step tutorial that I used under go.dev/tour. It will help you go step-by-step learning Go, starting from basic primitive types, control loops, infrastructure interfaces, things like that. I found it a simple language to understand and to learn, especially if you have knowledge in other programming languages. It's compiled which I like because the compiler now finds errors that you don't bump into during runtime. One gotcha that I found that there are no exceptions, meaning you need to explicitly check for error conditions for function calls. Otherwise, your code will just panic out. Remember that, check return values, the underscore ERR return value is your friend. HashiCorp's documentation is the thing that documentation used and it's recommended. It's located in their development portal under the link here. And you can also scan the QR and find that. Read the docs again, and they will give you a basic understanding on how strings plug into one another. After you've learned Go, you read the documentation from the HashiCorp's documentation, you can go ahead and create a provider. And I was using a demo to make this a bit more real. This demo is a plugin that manages lines in a text file. Simple lines and simple text files. All files are managed in a single path. There's a file resource that has a file name and a lines array. The file API was provided for you by me and is limited. It doesn't have a lot of primitives. You could read line, you could write line, you can count number of lines in the file, but not a lot more than that. And you can see that the resource definition on the left, which has a file 1 and 2 lines, line 1, line 2, maps into a file that has 2 text lines. You can grab the code under my GitHub repo, Safra, Terraform provider file data. You can also scan the QR to get there. The Terraform plugins framework is the recommended way to creating providers. There are 2 or 3 different ways, and an API specification change. The new way is the plugins framework. It allows you to manage your business logic and focus on your business logic, and have the plugin framework do the hard lifting of connecting to Terraform Core over RPC. And you start working on that by cloning the Terraform provider scaffolding framework repo to your private repository, and then you can customize it from there. When working with Terraform, there are 4 basic operations that Terraform Core needs to be able to run over infrastructure. They provision the infrastructure, and they amend the Terraform state accordingly. The create operation obviously creates the resource. It could create a file, in our case, but it could also create an EC2 server. It could also create a user in a managed SaaS database. The read operation reads the current infrastructure state. The update operation changes attributes that can be changed according to the API. Obviously, not all attributes can be changed. If we go back to the EC2 example, if you want to recreate the EC2 server, some things can be updated, like the SSH key, to destroy and create it. But some attributes can be updated, and the update API does that. The last operation is delete, which removes the resource. And Terraform Core also uses that for recreate operations. In case a user wants to change attributes that can be changed without destroying, Terraform Core will go ahead and delete and recreate the resource by using destroy and create again. If you look over the code, you can see that this is the repo I cloned. And there are a few things that I mentioned earlier. The file API that I provided for you has a few basic operations: read, write, count the lines, remove files, and remove lines from the files. That's something that I add. The documentation and examples. And if you click our resource here, the file resource, you can see that each of the primitives that I mentioned earlier has a method associated with that. So we have a delete method, and an update method, and a read method, and a create method, and a few others that we'll cover a bit later on. And if we expand the create method, for example, we can see that it has a code that has to do with interfacing with Terraform Core. It basically gets it copies the request from Terraform core into a local variable. Then there is logic that does the operation in the infrastructure, in this case, creating a file and writing lines into it. And then it returns value back to Terraform core to allow it to know what happened and allow it to amend the state accordingly. Each of the resources and data has schemas and attributes. Schemas and attributes are the mapping between Terraform configuration blocks to provide the code. And they define what parameters are needed to create the infrastructure, to change its values. Some of them can be mandatory, some of them can be optional. But these are the parameters that are needed to create the infrastructure itself. Schemas have attributes that define specific data elements. And each attribute has a type. A type could be a primitive, an int64, or string, or it could be a complex data type like a map, an object, a list. Each of the attributes also has properties. Description, it's optional, sensitive, and other properties. And can also have optional validators to check that the user's supply values match what the infrastructure and provider are expecting. If you take a look at the code, you can see that this is all implemented in a schema function. And the file has two attributes. First of all, the file itself has a description, file data resource, and it has two attributes. One of them is a file name, which has this description of file name. It's required. And has a validator that forces the file to match a specific regular expression. It also has an additional attribute called lines, which is a list attribute. And each one of those is a string value. So it's a list of elements of type string. And in this specific case, it also has a validator that forces the line file to have at least two lines, just as an example. If you note the descriptions under the attributes and on the file name, do use them because they are then copied over to the automatically created the documentation that basically copies the description and file name and an element type here. And then you can see this documentation later on copied into and published into Terraform registry for your end users. Types. The plugin framework types are not native Golang types. They have additional methods and functionality to handle null values and unknown values. For example, in int64 and other primitives have an isNull method that returns if it's null or not. And primitives are actually using the value type method. For example, the int64 has a method called value int64 that returns a native Golang int64. Collections are converted into Golang types with the as methods. For example, list, you can grab the elements of a list as native Golang type with elements as, and then cast them into a slice or array of strings that you need. If you go back to the code, you can see and go back to, for example, the create function. You can see that the full name of the file is created by appending the base path for the provider with the file name, which is a framework string type, but we grab the value, the Golang value, with value string, and that returns it into a native string that we can use to append into other values. After you created the provider, you're quite happy with that. You want to run it. You want to test it. You want to see that it works. First of all, you don't have to publish the Terraform provider into Terraform registry to run it. You can use to run it locally. You can do that by using the dev overrides. Stands inside the CLI configuration file and then send the TF CLI config file to that file. In this example, you can see that the CLI config file has a dev override that maps the registry address into a local path on my Mac. You can use log-based debugging for simple cases, but you can also use debugger-based debugging, which is far more powerful for complex ones. So you do that by running the main method of your provider with -debug equals true. It will output an environment variable. You copy it to wherever you want to run. And then you run Terraform action. And then the action will break the debugger. Let's see how that works. First of all, I have my code here. Let's look at the run configuration. You'll see that everything works correctly. So we have a debug, and you can see that the program arguments have -debug equals true. I set a breakpoint. For example, let's say I want to debug the read operation. So I set the breakpoint here. And then I run the program. It will compile and then output an environment variable, which I copy. And then I paste here as it is. Now, this directory has a configuration for Terraform. So it has a provider block, a provider file that defines the base path, which is this exact directory. It also has a resources file that defines two file resources, file 1 and file 2. You can see that each file has a few lines. And if we cap the file 1, for example, you can see that it has 2 lines that are defined. As I mentioned earlier, I exported the TF3 attached providers environment variable. And now if I run Terraform plan, it will start. And then it will pop up the debugger. And you can see that the Terraform run itself is waiting for the debugger output. You can use the debugger to just basically scroll through your code like everywhere else. And you can see, for example, that the full name here that is created is a read operation for file 2. If we resume the program again, it will continue running, and then it will end and refresh the state. If you don't need that, and you can see that it refreshes the state and the read operation. And in this case, there's no change in the file, so there are no changes in infrastructure. When you're done with that, obviously, you want to stop the debugger, and then we can go back to the presentation. After you debug your code, you're happy with your test, add automatic test and acceptance test for your resources and data sources, and to allow you both to check the code is working correctly, and what will later on interface into the GitHub Actions. The state is always checked implicitly in this test suite. And if you want to create and test operation by yourself on the infrastructure itself, you need to add them to the acceptance test. You can run the test manually with make test ACC. And the way it happens is you create a resource underscore test.go file in the same directory, and the make will grab them. So if we go back to the code, close the debugger menu, you can see that, for example, the file resource has a file resource test underscore go. And this has functions. Each function is a test that has a pre-check, steps for the test. And as I said, the state is checked implicitly. For example, in this case, it configs with a function that we'll see a bit later. And then it creates a file, like file 1. It has 2 lines, 1 and 2. And it checks the attribute, just checks the attribute that the file name is file 1. The second step in this test is to actually update file 1 with lines 2 and 3 instead of 1 and 2, and check that the lines in the 0 place, and the first line is equal to 2. Both of these functions use a set of function, test x file config, but it could be whatever name you want, that just returns a Terraform configuration file, basically. So we have a provider stanza and a resource stanza. And you can see that the values are dependent into here just to make creating configuration files easier instead of just writing them here explicitly again and again. When we're done with that, you can run the acceptance test, and in this case, they pass, which is nice. You created your code, you debugged it, you created acceptance test, you created documentation, you're all fine and happy. You want to publish into Terraform registry. The first is create a GPG key that you will use for, and Terraform registry will use to validate that the code is indeed yours. Set the GitHub secrets, GPG private key, and passphrase accordingly. Create a Git tag named v on this v version. Could be v0.1.0 or v2.3. Make sure to follow semantic versioning, and this tag is what drives the GitHub action that's included with the Terraform provider plugin framework. And that action builds both all the executables and also pushes a webhook to Terraform registry to allow you to grab the new resources. So you need the tag, really. And the next thing is you log into Terraform registry and add the repo. Once you've done that, you authenticate back to GitHub. It will create webhooks that will push in new updates that are tagged into Terraform registry. And you wait a bit. It takes a few minutes and for Terraform registry to grab the changes from GitHub. And then you can see your provider published into Terraform for other people to use. Everything that's published into Terraform registry is available for the public. So be aware not to publish any kind of proprietary code or anything that's a secret that they can't really divulge. To wrap it up, me and my team started from manual management of this specific database. We have used Terraform extensively for other cases, but in this specific database that we need to manage, we had the manual management script and Confluence. I had to learn Go. I learned Terraform framework. I created a provider and released a few more features. I think on version 0.4 now. And I published the provider. And my team uses it. And I hope that other people around the world use it too, because it makes managing database easy. Thank you all for your time. I'm Harel Safra. You can find my contact details, LinkedIn, and GitHub profile below. I would be more than welcome any questions. If you have anything, reach out to me, and we're glad to help with anything that you need. Thank you for your time. Thank you for being here with me.